How much velocity does an egg need to break on different surfaces? Obviously, if it is on concrete or something similar, we know the answer is not a lot. I want to find out how much velocity it takes for different materials such as water or concrete. My hypothesis is that if I increase the height the egg is dropped, it will have a more likely chance of breaking.
My independent variable I will be using will be the different materials, and this is a qualitative data.
The materials I dropped eggs on were concrete, 6 inches of water in a plastic bucket, 1/4 inch thick of bubble wrap, a phone book, and oobleck.
My dependent will be the breaking velocity, which I will find using the equation square root of 2gh equals v.
Many variables will stay the same, such as the orientation of the egg when dropped, the size of the eggs used, and the initial velocity will always be 0. I will control this by keeping the egg vertical, using the exact same eggs from the same brand, and keeping my hand still when dropping the egg. To obtain sufficient data, I would increase the height of the egg in intervals of 5 millimeters. If it did not show any signs of breaking, I would increase the interval to 10 millimeters. Because of gravity, when an egg is dropped, it will go towards the ground. As it falls, its velocity will increase, causing it to build up kinetic energy. As it hits whatever it lands on, the kinetic energy will be transferred. Depending on how hard or soft this object is, the kinetic energy can be transferred rapidly or slowly. This is the impact time. The impact time is what decides whether or not the egg breaks. If all the kinetic energy is transferred quickly, the egg will most likely break. The materials I used were simply large eggs, a meter stick, the materials themselves, and the container for the materials such as a glass bowl. This lab is relatively safe, however you're going to want to pick up the eggs when you're done with them so that animals do not get sick from eating them. All you need to do for this lab is find a material you would like to test dropping an egg on, measure a height lower than what you think it will break at, and keep dropping the egg, increasing the height by some interval until it breaks. As you can see by my complex representation of my lab, gravity pulls down on the egg, and when it interacts with the material, it either breaks or doesn't break. This is a table of the data that I have collected. It lists the material that I dropped the egg on, the feel of the material, and the height that it broke. These are the calculations I did to find the velocity. I just used the equation that I mentioned before, v equals the square root of 2gh. This is the graph I made to represent my data, and as you can see, oobleck has the highest velocity to break and concrete has the lowest. I did not believe a line of best fit would be appropriate for this type of graph. In conclusion, I feel that I can safely say harder surfaces need less velocity to break an egg than softer ones. This is because the time of impact is longer on softer surfaces, causing the kinetic energy of the egg to transfer a lot slower than on something like concrete. Some limitations were height, as I could not go higher than 4 meters and make the egg hit its mark. Most of the materials were over concrete, but one was over soil, so my data might not be exactly correct. The weakness I had was the inability to completely get accurate data, as I would have to use a crazy amount of eggs to do that, but that would be wasteful and expensive. For improving this project, I should have made something to guide my drops so I could make sure I hit the mark. I should have also set up more protection around the material I was dropping the egg on so it wouldn't break from missing or bouncing out. And that is the end of this video. Thank you for listening.